digital controller. Nowadays we use digital controller. So we pass them to the unit. Here, in most of the power converter, in 99% cases we use high-end microcontroller. So I just introduced the word microcontroller, and for rest of our discussion we will focus only on microcontroller. But then, just to complete the topic, I will show some important component of the power converter before, and then we'll spend time on a microcontroller. So here we can see that it is more like the closed loop system where we have the plant, that is the power converter stages. Then we have the feedback through those signal conditioning circuits. So for example, we have input voltage, output voltage. They are a bit higher voltage compared to the ADC channel, which can accept or we can say the ADC port voltages. They are limited to 0 to 3.3 volt or 0 to 5 volt. So we need to convert this high voltages, high current into appropriate form, and then we need to process to microcontroller. So in between we'll have a lot of circuitry, so that we call it signal condition circuit. So we'll again have a brief discussion on signal conditions. So in addition to that, now it's working but not over the screen. So in addition to the signal condition circuit, we can see that communication controller. So most of the modern microcontrollers, they have many communication modules, including Wizard, or we call it SCI, then SPI, then CAD, then I2C. So nowadays, considering the need of these communication lines, the modern microcontrollers, they provide these modules. But apart from the internal modules, we need some ICs, you can say driver ICs or communication driver, we need to have along with the communication port. So if you open any cabinet or chamber of the power converter, you will see this type of network. So one should correlate this block diagram with the circuit which we see over here. So these are the system we developed in our company and laboratories. So same thing, we can see the microcontroller section, we can see this power converter stages, say for example 3-phase voltage source converter, boost half bridge model, and the driver driving this converters. So in addition to that, you will see passive components like the capacitors. Beneath that, you will see some inductors, transformers, and so on. So those circular discs, they are the capacitor bank. And for this plant, so we can refer this as a plant, what we can say, the power converters. To drive this power converter devices, we have driver circuit. To get the feedback from these power converter, say for example, input voltage, output voltage, current, temperature, we use this signal conditioning circuit. So then the interface, that is between the plant and the power converter, we achieve through this signal conditioning circuit, driver circuit, and we process the what we can say, we control the entire power converter to that main microcontroller, DSP controller or main microcontroller. So you will collect all this feedback, you will have some control strategy. So that is the part of research. Many of you, your MTech students, PhD students, and there are my respected faculty members. So we do all our research in developing the control strategy. We model the power converter. Then we develop the control strategy like inner current control loop, outer voltage control loop. We use PI compensator, we use filters, and so on. So what do? We used to use those analog based control. But then for the power converter of high rating and a bit challenging power converter, it's very difficult to achieve the closed loop control using analog control, like operational amplifier. It's one of the way of achieving system control, but then that is outdated technology. We use this modern, highly versatile microcontroller, which is, I think it's a general purpose microcontroller, where we code our control strategy. So we have feedback and we have outgoing signal PWM, which is, I said just HMI or human machine interface. So do you have any idea of HMI? Any response is fine. It doesn't need to be accurate. In fact, it's a very general question. Any idea? What is the meaning of HMI? Small response is good enough, just to motivate me to keep on staying. I'm not here to test anyone's quality, I'm sorry. So just to have some interactive session, I thought to just have some question in between. So as name indicates, human-machine interface. So we have this power converter, but then we want entire thing to be fully automized. That's fine. But then some human intervention is necessary, at least for turn on and turn off, isn't it? So, or you may have some interface for increasing the speed or decreasing the speed or increasing the power level or some XYZ parameter. So that interface is important in some cases, not always true, but then in most of the cases we require some interface between the operator and the power converter. I give some just example like if you want to increase the speed of motor, control to this power converter, you need to have some button. Either over the cabinet you will have button, or you may have this type of remote control. So this is IR this remote control. So we'll discuss a bit on this remote control also. So and in addition to that, human machine also involve the feedback mechanism to the user. Say for example, user should know what is the input voltage or what is the output voltage. If not of his concern, then at least he should know what is the energy or the revenue generation or whatever parameter. Say for example, actual speed and something like that. So we achieve this interface through, for example, display, keypad, through this IR this remote, isn't it? And these are the HMI components. We process these HMI components through microcontroller. So again, we are discussing the relevant topic of this workshop, that is microcontroller. So inside this power converter, very briefly, within 2-3 minutes, I conclude this power converter topic. So inside power converter, use this IGBT modules, that is half-bridge IGBT module, and the white one and the lower one, the black case, the 3-pin, it is a Q247 package MOSFET, power MOSFET. So signal MOSFET, they are very tiny, but then in power electronics we use slightly bigger casing MOSFET like Q220 package, Q247 package, and then this half-bridge modules for higher power capacity power converters. So we mount them on a heatsink for thermal management, and then somehow we establish interface with the PCBs. Okay, so PCBs are printed circuit boards. I heard that your institute procured a very fancy PCB fabrication system. So you please take advantage of that facility and try to develop some electronics. And there you require these PCBs. So we interface, we somehow install these IGBTs and MOSFETs on our power board, and then rest of the power converter we try to find. So for example, the IGBT module, it is installed over that PCB. The IGBT is at the beneath, and from the top side we screwed the IGBT module. This is one of the way we can develop that power stack, which has DC-AC or AC-DC conversion. So there are different types of IGBT modules. So in addition to the IGBT module, we use the inductors and the high frequency inductors and the power frequency inductors in a power converter. There one can use the toroidal cores, EE cores, ETD cores. They are the ferrite inductors. And we hardly use the ferrous cores because they are not suitable for the high frequency. They are good up to 400 Hz, but most of our power converters, we drive it 5 kHz to 100 kHz in that range. So amorphous core is one of the preferred choice for the high frequency power converter. And then we use such a bulky capacitor. So you know, most of you, some of you work in electronics. So you must have seen tiny ceramic capacitors. They are good for the signal level. But in power converter, we require this type of bulky capacitors. So, for example, 450 volt, 470 microfarad the electrolytic capacitor and that distilling metal spin capacitor. So using this component, we, we fabricate the power converter. Okay. These are a few pictures of our prototypes we developed or something. And at the end, so with your effort, maybe over the 6 month or a year, you will develop a power converter, and it should look like that cabin with the proper PCB, all the components and so on. So when I started my journey in power electronics, I fabricated a small circuit on a brick. That is the very first system I explored. And then later I realized that okay, breadboard is not the one I should use further because it has a lot of limitation, right? From power level, signal integrity, and a lot of other things. Then later I used zero PCB. You must be knowing zero PCB, where we mount the through a component and then we solder and then we try to connect through wires. That was fine to a certain extent. But I realized that the performance from that, even that zero PCB, is not good. So then I moved to PCBs, because I used to see PCBs in a power converter and in an electronic application. So I took a lot of time to reach from breadboard to PCBs. So here is my suggestion for early researcher. So instead of just wasting your time on a breadboard, breadboard is fine for fit testing of some small model, but certainly not good for testing complex electronic circuit. So here is my advice. Try to develop PCB. Try to architect your circuit and mount them on a PCB. Luckily, your institute has that facility now for PCB fabrication. Other institute, they generate the Gerber file, they give those Gerber file outside and get the PCB fabricated, and then they do the prototyping. That is very good practice. You will get a very good signal response. You will get very good thermal management function. Don't stuck up your don't put a lot of effort on breadboard based prototyping. That is just my suggestion. So it will save a lot of your time. So you may be thinking that breadboard is much more critical. Then why am I suggesting you the PCB based approach? So breadboard, unknowingly there will be lot of issues you will be handling in overcoming the parasitic components. Okay, so breadboard, the PCBs are like your own architect. You will be laid down the track, you will be laid down the footprint. Okay, so though generating PCB may take maybe a month, but then response will be much more better on a PCB over the breadboard. So inside that you will definitely find, let's say you develop some power converter, you find the power stages, and then microcontroller driver circuits, so on. Then after that, then HMI component like the SD card, LCDs, keypad, RTCs, and so on. So we intentionally and deliberately add this auxiliary microcontroller and lot of HMI module. For what reason? What is the reason of adding a lot of such a components? Because today's world is very fascinated with the fancy gadgets. Like we want touch screen, we want good screen, we want SD card, and we want lot of fancy features like the Bluetooth, Wi-Fi, and so on. So by putting a little more effort, you can increase the value of your product. So during learning phase, try to learn these modules like keypad module, LCD module, SD card module, GPRS module, and believe me, they will be much more useful to you compared to the past stages which you are planning to develop for your research. Because this module will be common in most of your power converters. So it will be one-time effort in developing this auxiliary module and then using the same module repeatedly over all power converters. Isn't it logical? So when you are doing research in developing power converter, do not limit your research only on developing that DC-DC converter or AC-DC converter. Spend some time in developing the fancy LCD or LED display screen. Why? Because that will give you a means of testing your power converter. Say for example, what voltage you have at the output, what voltage you have at the input. You don't need additional multimeters to connect and increase the complexity in your prototyping. You know, when I was a research scholar, when I was a student, that time I used to use lot of multimeters next to the power converter, lot of hanging wires, and then unintentionally there will be a lot of mistakes in testing the power converter or prototype. But then imagine that you have this module sitting next to your prototype. You don't need to have a lot of multimeters or say for example DSOs, complex DSOs. You can achieve, you can have easy debugging atmosphere. You know, debugging means what? Debugging means the what we can say resources for testing your power converter and for fixing the bugs in your prototype. So there is a saying by a famous professor: if you do not fail in your prototype, you are not a good researcher. So you will always have some fine. So okay, so I don't know if it makes sense or not. But we'll continue our discussion.